So welcome everyone, a very, very warm, literally warm welcome to everyone who's joining us for this final seminar in our Heroes and Villains in the Anthropocene series. This is being run, for those of you who don't know, as part of the Global Lives of the Orangutan project at Brunel University in London. So welcome back to those of you who've been attending this seminar series. It's great to see you here again, and welcome to people who are just joining us for the first time. We're very, very pleased today to have with us three researchers, three cultural and environmental geographers from the Department of Geography in Cambridge today to talk about ruminations with climate cattle. So the presenters today are Jonathan Turnbull, Catherine Oliver, and Adam Searle. And as I said, they're all based at the Department of Geography in Cambridge. And between them, they've got quite an impressive range of interests in more than human relations, in emerging ecologies, emerging technologies. But today, I'm very pleased to see that they're combining forces to talk about Anthropocene atmospheric animals, ruminations with climate cattle. So welcome, Johnny, Katie, and Adam. It's really good to have you here. And I'm now going to hand things over to you to take things away.
Thank you so much, and thank you for having us. We're really excited to be here. We've been working on this project for a few months, and this is the first time we're presenting it. So thanks everyone for coming as well. So to start off, we're going to try and show you a video. And if the video doesn't work, we're going to post it in the chat. But hopefully it'll work.
When cows fart and burp and splatter, well, it ain't no laughing matter. They're releasing methane every time they do. And that methane from the rear goes up through the atmosphere and pollutes our planet, warming me and you. Yes, that methane that they pass is a greenhouse gas that'll trap the sun's heat and change our climate too. Gee, is it hot in here, or is it just me? So to change their emissions, Burger King went on a mission, testing diets that would help reduce their farts. That's a start. And now they're in question that it's helping cow suggestion, adding land and grass so they can play their part. Reducing methane, and the scientists have proven that it works. Reducing methane, we can reduce emissions by more than a third.
My cow ain't farting. Must be me.
Reducing methane, and the formula is free and open source. So join in, reducing methane. Got the cow kids singing for a better world. Got the cow kids singing for a better world.
So in this advert, Burger King are talking about their methane emissions and the changes they're making to cows' diets in order to reduce their impact, the production of methane and their impact on the climate. And so we want to draw particular attention to these lyrics. To change emissions, Burger King went on a mission, testing diets that will help reduce their farts. So Burger King's claim is that by converting a proportion of their cattle's diets to lemongrass instead of corn, they'll produce less methane, reducing the contribution of their beef burgers to climate change. By feeding cows a diet including lemongrass, Burger King promises that consumers can continue to enjoy burgers with a lower environmental impact. The alterations in the diets of cows are undertaken by meddling with bovine metabolism, whereby cows' bodies become sites of climate governance. Metabolic manipulations have become a way to produce climate heroes, good cows for the good Anthropocene, whilst other non-engineered cows are constructed as villainous climate destroyers whose metabolic processes are undesirable and unsuited for good Anthropocene agriculture.
Oh.
So attention to metabolism entangles geographical scales. from the molecular to the planetary, in the rumen of cows, which have become a site from which to engineer the climate. In this seminar, we're drawing on expert interviews and media and scientific discourse analyses to understand how these climate cows overflow the Anthropocene hero-villain binary. Over the next 30 minutes or so, I'm first going to take you through the context of climate cows and their rumens, before Adam dives into our empirics and our early findings from our research with scientists, businesses, and farmers. And then Johnny's going to conclude the seminar by framing these ruminations via the concept of metabopolitics, returning at the end to the question of heroes and villains in the production of climate cattle. So over the last few months, we've been interviewing scientists and businesses, developing products to manage and manipulate the climate through bovine rumens, as well as the farmers who are using these products. These conversations have also been playing out in real time in the media, with rumens becoming externally relevant. The agricultural industry has seen a huge turn to gut health as the primary concern for the future of farming, with a focus on gut health as being the neglected ingredient in many animal industries' productivity. Nowhere has this become more potent than in bovine rumens. In 2016, anthropologist Radhika Govindrajan proclaimed, "The Anthropocene is the age of flatulence," drawing attention to the effects of cattle-produced methane on the climate. Notably, however, methane produced by cows primarily emerges by eructation or burping, rather than flatulence. Govindrajan captures an Anthropocene problem that, as Burger King admit, is in need of fixing. As ruminants, cows have stomachs with 4 parts: the rumen, reticulum, omasum, and abomasum. The one that has received most attention, and indeed that we are focusing on, is the first, the rumen, where microbes break down food via enteric fermentation, producing the notorious climate villain, methane. So the average farm bovine produces up to 200 kilograms of methane every year. And ruminant methane production is a serious concern for climate scientists because methane is a powerful greenhouse gas, 80 times as potent as carbon dioxide in its heat trapping capacity. Farmed animals account for around 15% of global greenhouse gas emissions, and around 40% of this is from cows' digestive processes. Methane from farmed cows accounts for approximately 1/3 of all emissions from agriculture, which, with global numbers expected to rise from around 1 billion cows to 2.9 billion cows by 2050, means these burps and farts present a serious problem for scientists and farmers, and a serious opportunity for capitalist solutions to intervene. So the cows that people eat are far from natural animals. Rather, they have long been engineered with goals of efficiency and docility in mind. But this engineering in recent years has been amped up through efforts to reduce methane emissions and save the world. McGregor and Houston note in their 2017 paper that climate cattle are imbued with techno-fix logics, whereby greater investment in science and technology, farming practices, and cattle biologies are reshaped in climate-friendly ways. The prospect of technologically enhanced efficient cows has led to significant investments in experiments with methane reduction. And in this talk, we're going to be focusing on just one kind of these, dietary experiments in the rumen. However, experiments on cows have a much longer history, which I'm going to talk a little bit about here. So cows were first domesticated for meat and dairy around 9000 BC and have since been subject to selective breeding, producing many different localized breeds. Cow penning and dietary controls were introduced over a century ago in the US to produce more effective cows who metabolize feed efficiently into muscle or milk. In the early 20th century, these rudimentary controls of the rumen through diet and enclosure had morphed into more invasive procedures and experiments to control production. So by the early 20th century, these dietary experiments often occurred and continue to take place via a procedure called cannulation. Cows are cannulated via a permanent hole called a fistula being cut into the side of their body, and a cannula, a tube made of thick plastic, is inserted into this hole to keep the rumen open. This is sealed with a removable cap, allowing food to be deposited and removed from the rumen by human keepers at will. And this is what's pictured on this slide. So historically, cannulation was used to understand how cows' stomach pH varies throughout the day and to evaluate the effectiveness of different feeds on the digestion of cows. It was developed in the early 20th century, first being used on cows in the 1920s at US agricultural colleges. a logic of capital is inscribed into this technique, as agricultural colleges have the improvement of animal efficiency and that of their byproducts as their core principles. So intervening in bovine metabolic processes with the aim of lowering methane emission is a more recent phenomenon. The discourse around climate-friendly cows or super low carbon cows is encapsulated in a media byline that reads, "Inside the hard-working stomachs of these cows, an experiment that could potentially change the planet is taking place." So while a range of techniques for producing climate-friendly cattle are being developed, these continually return to the manipulation of the rumen. So this range of dietary shifts that have been proposed to lower cow methane production, based on the idea that much like human digestion, reducing fibre will reduce flatulence and therefore reduce the production of methane. Legumes and oils have been added to cow feed to reduce the fibre, and some UK farmers have switched their feed to maize, which might reduce methane production by 10%. More recently, lab trials have shown the addition of asparagopsis, which is a type of seaweed, to cattle feed could potentially eliminate altogether emissions of methane. Asparagopsis produces bromoform, which prevents the formation of methane in the rumen, an intervention that works similarly to that of Burger King's lemongrass, talked about in the advert at the beginning. So these dietary shifts aren't without problems, as the microbes that break down these introduced foods are different. Cows have to be monitored carefully for bloat and other health problems. By making cows more efficient through their diets, they are alive and belching methane for a shorter time. These techniques are firmly rooted in anthropocentric and objectifying conceptualizations of non-human animals, reflected by the support these experiments receive from venture capital funds and huge consortiums of food companies. Dietary changes for cows reinforce an eco-modernist commitment to techno-fix solutions to Anthropocene problems, presuming economic efficiency and productivity can be increased without necessitating any change to the human status quo, such as reducing beef and dairy intake. This fascinating history of the rumen as a site to engineer the climate attracted us to interviewing scientists and farmers about the rumen experiments that are going on now, to understand how these ideologies are written into and onto the bodies of cows. So before Adam shares some of our empirical findings, I'm going to briefly end this long introduction with the multi-scalar vision and the ethics of that vision that we've found in the rumen. So cows as villains and potential heroes is a relatively recent framing, and one that attaches the future to an enduring present of colonial capitalist expansion. What we find in the metabolic manipulation of the rumen is a form of governance that reveals the position of cows at the nexus of a power balance between decision makers, governments, capitalists, and producers, as well as consumers. As Garnett and Dodd-Free argue, the stability and security of the food system is underpinned by its environmental resource base. The evidence overwhelmingly suggests these resources are being depleted and damaged in ways that threaten food production in the long term. And much of this damage is caused by the food system itself. Food is both agent and victim of environmental harms. So food systems research has pivoted in the last few years to questions around the relationship between a good diet and a sustainable diet for the global human population. But this often omits the relationship between the food that we eat and the food that our food eats. So food systems are increasingly understood as produced and consumed across multiple political, economic, technological, sociocultural, environmental, and biophysical drivers. And classically, food has been produced and fortified for humans through dietary supplementation, and the ruminant experiments that we're discussing here follow in this lineage. However, they push beyond this traditional fortification as they seek not only to improve human diets, but to manage the global climate. So these projects are incredibly valuable to capitalists and corporations, to governments, and to producers hoping to develop a niche in a competitive market. So around the space of the rumen, there are a whole host of actors circulating around and across this binary of hero and villain: scientists, farmers, investors, entrepreneurs, and of course, the cows themselves. So in this talk, we want to start to trouble these notions of hero and villain by understanding how those structures have been applied to cattle, how they've affected bovine business, and how they shape the visions of the scientists who think the rumen is the site at which they will save the world. So I'm going to hand over to Adam now to talk about our empirics.
Thanks a lot for that, Katie, and thanks for that really kind of wonderful outlines, the conceptual frameworks and the broader kind of discursive context that we've been thinking about here. Yeah, so after thinking about this shift in intellectual and conceptual arena in which bovine rumen are becoming enmeshed in systems of global environmental governance, we went out to interview some key figures in this field. This included scientists based at one of the world's leading laboratories in research regarding bovine microbiomes and enteric fermentation, working in both agricultural science and synthetic biology, people working at one of Europe's leading companies marketing so-called climate-friendly cow feed supplements, which for purposes of participant anonymity, we have renamed Removable, and farmers working with these products, kind of on the ground, working with the cattle themselves. Yeah, and in the coming months, we really hope to be able to supplement this research with kind of in-person observational field work in both laboratories and in farms. But at the moment, as I'm sure everyone's aware of, we have had to conduct all of this research online via online interviews. So in identifying the construction of expertise regarding bovine rumen and its role as a site of global environmental governance, it's really crucial to note here who has the claims to authority and whose knowledge is sidelined, and how our own work can serve as replications in these biases. All of our research participants were based in Europe and North America, themselves both very different in their institutional and ethical framings of cows and technologies in the climate crisis. Participants were based entirely on their prominence in both scientific and media discourses, and thus we can only really offer a small snapshot of this changing climate. There are a multitude of meaningful more than human relationships that are left out by this work. And importantly, our research participants by no means shared a universal vision for the best ways to intervene in agricultural systems for so-called sustainability. Their common concern, however, was on an engagement with bovine food systems based on efforts to increase the secondary productivity of cows. In other words, to tweak environmental, biotic, and chemical conditions in order to increase metabolic efficiency, to increase mass production from food input, and thus, by consequence, reducing waste via things like enteric fermentation. Whether or not this was the production of so-called climate-friendly cows for environmental or for economic reasons depends on who is speaking and creating these frames, although in all cases, it's probably likely a mix of both. So for the most part, scientists are experimenting with feed manipulation as the primary area of intervention for reduced emissions, adding supplements to cattle diets, including asparagus, lemongrass, garlic, citrus, or seaweed. In an interview, one scientist in approach to bovine metabolism has been achieved firstly through simulating the metabolic pathways involved in methane production using computer programming, and then examining these chemical processes in laboratory conditions. The scientist told us how the seaweed was incubated in the laboratory with some rumen samples taken from the stomach of the animals, and then we measured the metabolites being produced to understand whether it could work in real animals. Here, the binary between laboratory and field is unsettled, a topic to which STS scholars, anthropologists, sociologists, geographers, and other social scientists, among many others, have explored in depth in relation to many cases. What's interesting here is the rumen itself is on this binary. The scientists we spoke to framed bovine rumen as specific sites of metabolic intervention, as a series of inputs and outputs, internalities and externalities. Here, the rumen is a laboratory in and of itself, almost distinct from the individual cow to be controlled and tweaked. But at the same time, the rumen is a messy field site, differing from cow to cow. And importantly, as I'll discuss in a second, really a deeply diverse ecosystem of microbial life in and of itself. As one scientist explained, the rumen is basically where almost everything happens, right? It basically contains thousands of different types of microbes all working together. It's the direct tweaking of this microbial activity within the rumen that allows for the reduction of greenhouse gas emissions. The scientists we spoke to focus specifically on this living microbial community rather than the cow itself, with one of us telling us the attention goes to feeding cows, but really this is about feeding the rumen and the rumen microbes. The focus is on the rumen and the microbes present, the protozoa, bacteria, and archaea that produce the methane. As this entails, as we'll discuss later, a shift in attention away from the bodies of individuals, but towards microbial communities themselves. It decenters the agency of cows and in a way renders them as vessels for these ruminary processes when thinking about multiple scales of metabolism. Interventions in these processes typically work in two ways. Firstly, by manipulating the rumen microbiome itself so that it contains less methanogens, which are the microbes that produce methane when they break down food, or by directly inhibiting the enzymatic activity of these methanogens, which is what we'll talk about now, which is how most of the feed manipulation works. So where does feed manipulation fit into this ruminary process? And how does it reimagine cows as planetary heroes and or villains in the Anthropocene? By changing the dietary composition of cows, scientists were able to activate different metabolic pathways within the rumen and activate or deactivate or drastically reduce the activity of methanogens. These methanogens are microorganisms, they're archaea, not bacteria, that produce methane as a metabolic byproduct in hypoxic conditions, which are when there's no oxygen or very, very little oxygen, as is the case in the stomach or a rumen. So human beings, we also have methanogens in our intestines, which cause flatulence, but in cows, they mostly trigger belching via enteric fermentation. As a scientist working for Renewable told us about their product, this was the primary function of their feed supplement derived from garlic and citrus, which causes a direct inhibition of the methanogens present, up to a 38% reduction depending on the rest of their diet, the species, and whether it is a beef or dairy cow. Feed manipulation could be a way of, as another scientist put it, working with the microbes in the rumen to reduce emissions without affecting the cow's growth. Renewable's website discusses their produce as a simple change to bovine diets with huge implications, noting that methane is 84 times more powerful than carbon dioxide in the first 24 years of its molecular life, and therefore we should be focusing more on methane than carbon dioxide. In their words, this is a process of helping cows to help us save our climate. One of the business development team at Renewable told us that this product comes at a time when the world is looking for solutions and demanding that agriculture reduces emissions. Farmers are being blamed for not reducing emissions, but at the same time, not being rewarded if they do reduce them. So a large part of the business models involved in feed manipulation concerns the development of new market mechanisms to make more environmental practice accessible. Renewable have a team of scientists working hard to find ways of inhibiting methanogen activity, but also at the same time, they have a team of economists working to develop carbon trading schemes around the reduction of emissions. We might think of this as another case of what Elia Postolopoulou and Bill Adams call cutting nature to fit, in that quantification itself is the issue, allowing capital to commodify non-human life even further, in this case down to the microbial level. Such credits do seem a really long way off being implementable at international scales and across global supply chains, though. So one of the ways farmers have sought to make feed supplements economically viable is through the development of products for niche markets that are afforded through the use of such feeds. Some farmers we interviewed actually referred to their farmed animals as climate smart cows. And then they use these cows to produce high quality milk, which is marketed specifically to baristas. And these are really small scale farmers who would using this as a product, as a kind of opportunity for diversification. In interviews, they mentioned to us that the pricing out of small scale farming, which was largely attributed to the low product costs caused by the big four supermarkets in the UK, had left them with little options, and that diversifying their product using these climate friendly cattle was a productive response to kind of stay afloat in a very hostile market. So feed manipulation also sits within a broader context of technological interventions in rumination, an area of rapidly developing change regarding the contested position of cows as Anthropocene heroes or villains is the development of novel biotechnologies, notably in synthetic biology and the development of genetic engineering tools such as CRISPR-Cas9. Such technologies are receiving a lot of hype, and although their application in human germlines is a hugely contentious issue, there seems to be less of a public concern around their applications in agriculture. The editorial stance of Wired magazine, which is showed here, a magazine, if you don't know, it discusses emerging technologies and their cultural and political implications. This editorial stance makes it very clear in there that they're in favor of it, that CRISPR could give us a more humane world. Will humans let that happen? And it's interesting here that then CRISPR becomes the hero, and humans preventing these techno fixes with red tape and whatever are cast as the villains, as if it's broadly accepted in this framing that the concept of humane could ever reach a global consensus. And it's interesting here to think through the potentials and the potentiality of biotechnology being the hero rather than them in action in present. It's what Sang-Hyun Kim and Sheila Jasanoff refer to as socio-technical imaginaries. And it's these imaginations that become the hero rather than the technologies themselves. It becomes kind of embroiled in this spectacular economy of biotechnology that really can often fall out of touch with the real here and now of the technologies themselves. The people we spoke to, there were agricultural scientists working with ruminants who are keen to really explore this in future research. As one of the scientists put it, the technology is going to continue developing. There's a lot of debates about whether genetic engineering is part of the solution or not. In the US, we are able to work within regulations, but this is more difficult in Europe. To me, I just don't understand why genetic engineering, which is more precise, is not allowed when breeding, which is just a shot in the dark, is fine. It's easy to see how genetic engineering can make us more sustainable. Genetic engineering in this sense has been applied to bovines in the development of gene drives to create what are called polled bulls, which are essentially bulls born without horns to reduce human-bull conflict and management stress. But genetic engineering hasn't been directly applied to address concerns of rumination and methane production yet, although it is being explored as a means of creating feed supplements which activate desired metabolic pathways in a very precise manner. So synthetic biologists working on engineering plants for this refer to their work as thinking of plants like a biofactory to make certain compounds. If we're harvesting things like seaweed for animal feed, all of these things have a finite amount because of the material source that we grow and harvest it from. So if you can engineer other organisms to produce these molecules, then you can potentially increase the scale at which you produce them. It can be applied widely. You think, hey, the livestock is going to eat this anyway, but if you engineer changes, it can have an impact. So whilst the question of synthetic biology is not something that we're really exploring in depth here today, I did just want to flag it as a real interesting area in this debate, and it's something that is changing very rapidly and something that we will pursue in further research. And I just really want to bring it up here because it's not only are we seeing metabolism mobilized as a tool for environmental governance, we're also seeing the genome itself being re-envisioned as a site of intervention in these debates. So yeah, I'm going to pass over to Johnny now, who's going to really take the conclusions and the kind of theoretical implications from this work forward.
Okay, thank you, Katie and Adam. That's fantastic, setting the empirical scene. And I'm just going to trace now some of the theoretical implications of this story. So what I'm going to trace is some of these shifts in bovine and cattle governance through the concept of metabopolitics, which is something we've been developing for a while now. I'll start with some brief notes on the conceptual history of metabolism in human geography and cognate fields, and briefly signal some of the key thinkers working in this area. I'll then advance our understanding of metabopolitics as an emerging form of molecular governance, before offering some concluding remarks related to the theme of the seminar, Heroes and Villains. So human geography has a rich tradition of thinking with metabolism. Perhaps most notable is work concerning the theory of metabolic rift, developed by scholars such as John Bellamy Foster. Foster was concerned with rigorously and scientifically conceptualizing the dynamic interchange between humans and nature, in contrast to his contemporary scholars, who found little ecological value in Marx's writing. Foster showed that Marx was deeply attentive to the relationship between humans, labor, and nature, and indeed had theorized that ecological crises were inevitable under capitalism. In Volume 1 of Capital, Marx offers a definition of metabolism of sorts: a process between man and nature, a process by which man, through his own actions, mediates, regulates, and controls the metabolism between himself and nature. Through this movement, he acts upon external nature and changes it, and in this way, he simultaneously changes his own nature. In developing Marx's work, Foster suggested that the human-nature relationship under capitalism produces a global metabolic rift. The theory of metabolic rift contends that industrial capitalism as a mode of production has separated social metabolism from natural metabolism, which is the underlying cause of contemporary ecological crises. This apparent separation between humans and nature occurred due to agricultural production under capitalism, which accelerated the growing division between cities and the countryside, or the rural and the urban. Developing this early work, scholars have used the metabolic rift theory to help understand large-scale transformations of the natural world. Geographers in particular have developed it to understand the uneven socio-ecological processes that occur under capitalism, ranging from empirical concerns involving hydroscapes of the urban, atmospheres, and biodiversity, amongst other things. Later then, Jason Moore's work on world ecology offered an important critique to Foster's theorization. Moore troubled readings of Marx that underpinned the original metabolic rift theory. Specifically, he wanted to correct parts of Foster's work that located biophysical crises in one box and accumulation crises in another, which in turn reinforced the nature-society binary that geographers and others see as the binary separation at the root of many modern evils. Moore did this by emphasizing that the metabolic rift is not about separation of nature and society, but rather a reconfiguration and shift regarding the relationship between the two. Moore begins from the premise that capitalism does not have an ecological regime. Rather, it is an ecological regime, collapsing culture and nature into one process. Capitalism for Moore is a world ecological system where no natural material or social relation is off limits to being subsumed by capital. Capitalist relations then do not merely act upon nature, but move through it to ceaselessly search for and find ways to produce cheap natures, as Moore calls them. It's this work that we find most useful in contextualizing metabopolitics as a reaction to the environmental crises brought about through capital's inherent tendencies. The second area in which metabolism has been a popular conceptual lens is within anthropology and science and technology studies. This work takes the body as a site of metabolic politics, exploring topics ranging from dietary governance to antimicrobial resistance. Scholarship in this area often engages productively with recent theoretical approaches to materiality. Here, the work of Hannah Landecker is exemplary. Across numerous papers and with precise detail, Landecker outlines the history of metabolism as a biological concept and its import into the social sciences as a political concept. For Landecker, organisms represent a ceaselessly churning scene of incorporation and excretion in which machines, bodies, microbes, enzymes, toxins, and nutrients are moving and converting matter into different forms. Here then, metabolism is concerned with a cumulus of interlocking cycles, the interface between inside and outside, individual and environment, life and non-life. This corporeal metabolism describes the endless becoming of organisms, which Landecker describes as the constant becoming of the machine itself. Paying attention to capitalist interventions into metabolism, like climate-friendly cattle, draws empirical attention towards systems of interlinked processes rather than things, according to Landecker's theorization. And this is exactly what we're aiming to do here, to understand how the governance and management of life occurs through the governance of metabolic flows, processes, and the transformation of matter from one form into another. This lineage of metabolic thought has, in part, spurred a resurgence of questions concerning the boundary between organisms and their environments, as discussed by scholars for decades from Canguilhem to Ingold. For Manbarua, this work invokes metabolism to inform understandings of the governance of bodies, which is relevant to metabopolitics and its intersection with bio and anatomopolitics. The two approaches to metabolism I've just outlined are not mutually exclusive, as Manbarua and colleagues note. They do, however, emerge from different genealogies of thought, the first from Marx's interest in the work of the soil chemist Justus von Liebig, and the second via the work of the 19th century physiologist Claude Bernard. The challenge we face in contemporary work regarding metabolism, then, is to bridge these two approaches. How can they be brought together to understand the intricate materialities of molecular flows across bodies, whilst retaining a sharp political focus on the uneven distribution of ecological or bodily degradation due to extractivist colonial capitalist economics across lines of race, gender, and class, amongst other things? Hopefully it's become clear that metabolism, as Barrow notes, is a multi-scalar, plural concept, both everywhere and nowhere. It stems from both 19th century developments in the biological, chemical, and physical sciences, and from political economy. In the rumen of cattle, these two traditions meet, entangling the corporeal and the bodily with the planetary. These strands of thought constitute the launchpad for our theoretical concerns, so I now turn to how we're conceptualizing metabopolitics in the context of climate cattle. Interventions in the climate at large are being realized through bovine bodies and their microbial communities, at least in theory. This allows us to conceptualize a metabopolitics of more than human life, whereby the flows of materials from feed to rumen to the climate are calculated, governed, and controlled. I won't rehearse the empirical stories that Katie and Adam have already brilliantly outlined, but the concept we put forward comes from the idea that humans can engineer the climate by tweaking microbial processes in the rumen of cattle, materially stitching together the microscopic and planetary scale. Specifically, it's the metabolic pathways that lead to the production of methane that are the target of metabopolitical governance. Metabopolitics is a portmanteau derived from the joining together of two words, metabolism and politics, in a similar manner to the related Foucauldian concepts of biopolitics and anatomopolitics. Metabopolitics, we contend, is thoroughly more than human as it relates to flows of non-human materials across bodies and environments and across different scales. It's also a concept specific to the Anthropocene in that it emerges at a time when a host of toxics, such as microplastics, are known to cause problems to humans and non-humans alike as they cross biological borders, permeate bodies of all kinds, and interact with and affect the genetic code itself. The materiality of the Anthropocene, then, involves the disturbance and reconfiguration, both on purpose and accidental, of complex metabolic pathways due to anthropogenic activity. As Landecker notes, the air and the water are full of the byproducts of human endeavour. It's the flow of materials associated with capitalist industries that are brought into focus by metabopolitics. In his famous works, Michel Foucault traces the development of two forms of governance that come under what he called biopower, bio and anatomopolitics. The former is concerned with the exercise of power over populations, and the latter is concerned with the exercise of power over bodies. In Foucault's writing, as emphasized by Thomas Lemke, the French philosopher was attentive to how intervening on the milieu of a population could be an effective means of governance. Taking into account the milieu, or the material ecologies and circumstances that allow a body or population to flourish, was central to some of Foucault's ideas concerning power and governance. But since these concepts were developed in the context of French society over the last several hundred years, the material circumstances and scientific capacity to measure and trace materials and flows have changed significantly. Developments in both science and technology now mean materials can be calculated, measured, and quantified at the molecular scale, which was not previously possible. In relation to urban space, Raul Acosta describes how new forms of techno-molecular governance are made possible as biochemical flows are made traceable in urban waterscapes. As new technologies allow materials to be sensed at fine scales and flows of materials to be traced with forensic detail, new modes of governance are made possible, warranting attention on their own terms as separate from bio and anatomopolitics, although intimately related to both. Metabopolitical governance then applies to situations in which molecular flows are subject to measurement, calculation, and intervention, specifically those interventions that have consequences that extend beyond bodies and across scales. More precisely, it involves the governance of materials as they move through and are transformed by bodies, human and non-human. In relation to climate cattle, metabopolitics involves the governance of microbes, animals, and the climate by corporations according to capitalist logics. While we might consider metabopolitics of flows, anatomopolitics of bodies, and biopolitics of populations as intimately connected, metabopolitics specifically offers a means of retrieving a robust political economy concerning matter itself, as it reveals, in Man Barrow's words, the coercive effects of the social, material, and spatial transformation of nature, whilst retaining the benefits of the conceptual advances put forward by various new materialist approaches. The rumen is a site of such material transformation, where the atmosphere itself is apparently made and remade according to specific visions of the Anthropocene, in which humans continue to commodify and consume cattle, whilst attempting to do less harm to the environment. Cannulated cattle and climate cows thus serve as visceral examples of the porosity of animals' metabolic work and how bodies connect to wider material and ecological processes. In these bovine metabolic interventions, there's no distinction between working on cattle bodies or metabolisms and working on the atmosphere. In fact, these interventions show the inseparability of organisms and environments. Indeed, this entanglement is brought into focus by these practices of metabopolitical governance. The shift to intervening in the metabolism of cattle to act on climate change is reflective of how, in the words of Hannah Landecker, knowledge of metabolism in the post-industrial period is suffused with environmental risk, regulation, and information. In tracing these bovine metabopolitics, we build on a rich tradition of research in the field of bovine biopolitics, contributing to it by going beyond bio and anatomopolitics to attend to the governance of circulation and the modulation of flows that exist in the atmospheric rumen of cattle. Cattle are governed not only as forms of lively capital, as bodies or materials for consumption, but as planetary scale actors, as atmospheric Anthropocene animals. So to offer some conclusions, I'm going to return to the theme of the seminar. Throughout this talk, we've empirically discussed how the rumen has become a site for climate governance, the organ through which climate politics, as well as food politics, are enacted. To understand the process whereby researchers and companies view the rumen as the container of metabolic pathways that can be manipulated, we've developed the concept of metabopolitics to conceptualize how molecular flows are governed across scales, which we hope others might be able to find empirical resonance with in other scenarios that involve the governance of metabolic flows, such as in synthetic biology, genetically modified crops, and the cultivation of other climate-friendly agricultural animals, as well as other microbial and microbiome experiments that are ongoing. Bovine metabolisms then are tightly controlled and experimented on in order to ensure the most efficient or carbon-friendly metabolic pathways followed in the production of dairy and beef. Here, cattle bodies are merely vessels for the rumen, containers of important chemical reactions, material flows, and metabolic pathways. But where is the cow in all of this? And might this whole industry be a distraction from alternative methods of fighting the climate emergency and reducing the production of anthropogenic methane and carbon? A critique leveled at climate-friendly cattle companies is their ability to divert attention away from more sustainable and effective modes of reducing greenhouse gas emissions, like reducing demand for dairy and beef by reducing dietary consumption of these products or refraining from them altogether. Moreover, cattle welfare is necessarily not at the top of the list of priorities for an industry that relies on the commodification of bovine bodies for profit. Despite this, some of our research interlocutors told us that they still considered their work as a necessity, as it ensured that as bovine products increase in popularity globally, which they're expected to do, they can be as efficient and climate friendly as possible. So questions remain, however, as to the accessibility of the feeds being produced and the techniques being developed. Will expensive and research-intensive cattle feeds be widely available or scalable to have the desired impact of reducing greenhouse gas emissions from bovine products? Thus, for us, the real heroes and villains are not located in the rumen of the bovine body. Indeed, the cattle as climate villain cum savior is more of a distraction from the issue at hand, namely the ongoing exploitation and commodification of non-human lives for profit and its intersections with the ongoing climate emergency. Instead of posing farting cows as villains and climate-friendly cows as heroes, we might look to the capitalist system itself as the villain in the background, which encourages and offers short-term rewards for techno-fix solutions that allow the lifestyles that caused the climate emergency in the first place to go on unchecked, such as the deforestation for beef production and cattle feed production. We're left then with some questions to take forward. How might these metabolic interventions encourage a business as usual approach to environmental governance? How will new technologies and techniques change these metabopolitical interventions? Who's the real hero and villain here? And where does the cow feature in all of this? So thank you everyone for your attention. And